Hi, welcome to another communication course. In this video, we will see the concept of single-tone frequency modulation. So, in the previous lecture, we have derived the expression for frequency modulated wave as S of t is equal to AC cos 2 pi fct plus 2 pi kf integral m of t dt, where AC is the amplitude of the carrier, Fc is the frequency of unmodulated carrier, Kf is frequency sensitivity, and m of t is my message signal. So in case of single tone modulation, the message signal contains a single frequency. So let's take the message signal m of t is equal to am cos 2 pi fmt. Okay, AM is amplitude of the message signal, FM is the frequency of message signal. Let's substitute this m of t in, say, equation 1. Okay, let's substitute equation 2 in equation 1. Then S of t becomes AC cos 2 pi fct plus 2 pi kf integral of m of t. In place of m of t, we have to substitute am cos 2 pi fmt dt. So as we know, the integral of cos is sine, right? So and this 2 pi kf, am is anyway constant, integral of cos is sine, but the constant factor comes as by 2 pi fm into sine 2 pi fm t. So 2 pi will get cancelled out. So this can be written as AC cos 2 pi fct plus beta sine 2 pi fmt, where beta is kf into am by fm, or it is delta f by fm. So beta is modulation index, delta f is frequency deviation, right? So delta f is nothing but kf into am. Say we know the unmodulated carrier is equal to AC cos 2 pi fct, right? And the instantaneous frequency of modulated wave is fc plus kf into m of t, right? In case of single tone modulation, we are writing m of t as am cos 2 pi fmt, right? So let's call this kf into am product as delta f, right? So this becomes fc plus delta f into some cos function. So the maximum and minimum values of this cos function are plus 1 and minus 1. So the frequency of FM wave will vary from fc minus delta f to fc plus delta f. Say the frequency of unmodulated carrier is fc, then this frequency is going to fc plus delta f or fc minus delta f. Okay, so this delta f is the frequency, maximum frequency deviation, right? So this delta f depends on the amplitude of message signal. It doesn't depend on frequency of message signal. Okay, and next we defined one more thing modulation index beta is equal to delta f by fm. Okay, now depending upon this beta value, okay, so we can distinguish the two cases of frequency modulation as narrow band frequency modulation and wide band frequency modulation. If beta modulation index is less than 1, then we categorize it as narrowband FM. If beta is greater than 1, we categorize it as wideband FM. So in case of narrowband FM, now I write the expression for narrow FM equation first. AC cos 2 pi FCT plus beta sine 2 pi FM t. Okay, so now by considering the two cases, beta less than 1 and beta greater than 1, we will simplify this equation further and we will draw the conclusions. Okay, so what is the difference between narrowband FM and wideband FM? What is the bandwidth occupied by a narrowband FM wave and wideband FM wave? So this discussion we will continue in next class. Thank you.